And welcome to the Bridge Show. We have a special treat for you today. So, without further ado, let the show begin. Ladies and gentlemen, it's Tuesday and therefore we are live from our IP-based studio in the basement of the Norwegian Oslo HQ of Bridge Technologies. Welcome. I'm so glad to see you all. I hope we'll soon meet again. I can't wait. But you are going to meet somebody very, very special, and a unique person which has been with, the industry kind of forever. Every single modern technology he's actually been responsible for co-developing, and the latest was of course him chairing the amazing development of ST2110 and all its ramifications. I would actually call him the father of modern IP-based broadcasting, and it's a pure pleasure to introduce from Imagine Communications, Mr. John Mailhot. Welcome, John.
Well, thank you. It's great to be here. Wherever here is in this IP world.
Yeah, the IP world is not going to end soon, is it?
Well, we hope not. I mean, COVID notwithstanding, IP has given us a whole set of tools to do production in an integrated way across many sites. It's something we've always wanted.
It's very, very true. And old story was that we started to build a Norwegian and actually Scandinavian media net very, very early, by the end of the 90s. And I believed very truly then that, it was only years until IP would break through the barrier and outconquer any other broadcast technology. And we started a network in just before 2000, and it's still running actually for contribution feeds. But we're still not there yet, are we?
Well, it all depends what you mean by there. I mean, as you say, you've built IP networks. They're used for contribution. They make television every day.
Yeah.
And if you think about the modern studio infrastructure, the uncompressed video signals are the last piece to go IP.
Yeah.
Everything else, the control networks, the tape, nobody uses tape anymore, the storage arrays behind all those servers, all these other things have transitioned to IP already. So our customers are in a position to really understand IP networks because they have to maintain their plant today. This is just the last, albeit big step, but it's the last step to moving to where we can, get rid of our fancy coax stripping tool maybe once and for all.
It's very true, and you're of course completely correct, because when we started the Scandinavian contribution network, it was already a vast array of IP-based distribution, because again, to local nodes in cable, everything, it was already going over IP, of course. And then, of course, it was the boundaries towards the very, very high bandwidth types. And in '98, 50 megabit 422 was kind of high bandwidth. Of course, now it's a laughing matter. So you're right. IP's been with us forever, and even in the late 70s, multicast was utilized within financial markets and military purposes, and was already quite developed as technology. So it's nothing new.
It's actually refreshing for once that historically the television industry has been the driver of technologies it's used. So if you look at like SDI when it was introduced, the idea of 270 megabits on coax was difficult. It took advances in drivers and receivers and equalizers, and then going to 1.5 gigabits and 3 gigabits was just exotic at the time. And then on and on we go. For once in this IP transition, television is not the leading driver of requirements. Instead, we have huge industries. We have the data center industry, the
Yes.
financial trading industry. As big as these IP networks we're building for television seem to us, to the switch makers, they call
Very
them
small.
medium,
Yes.
because in the scope of what Arista and Cisco and other large switch providers make, the requirements of the television industry are
Yeah.
interesting, but they're not the leader in
No.
terms of what's required. They're in the middle. And it's a very great place to be for us as an industry.
You're very right, because again, you can take advantage of all these new developments, which is then again done for different types of applications, and incorporate that without again the specialization, which is extremely, and have been up through the years, very, very, very expensive for the vendors. And that means that the vendors again can focus much more on TV specific development and not care that much about the overall architectural kind of glue that is necessary to bind all this equipment together.
Yep, exactly. And we can leverage the tools of the IT industry to get visualization of the network's tools, like from Bridge, for example, where it's the whole host of vendors that make IP networks accessible to the people who buy them every day. Many of those tools are not television specific, but then some of them have added television specific features to be enablers in our industry. So we're really glad to see that happen, because if we build a technology like SDI, then we're required as an industry to fund the evolution of all of the stack of test and measurement and other equipment that go with it. But when we leverage a technology like IP, then there's a whole other set of industries that are co-funding the development of that technology and all of the tools and visualization software that go with it.
Yeah, it's very, very true. And sometimes it's very interesting because, we kind of got PTP, both version 1 and 2, of course, from the telecommunications industry, which has been a heavy user of those technologies for quite some time. And then, of course, we adopted it into the broadcast industry. And now it seems like the data center industries or big data is actually going to repurpose a lot of the learning from the PTP usage in broadcast towards the data centers. And that's kind of, we're starting to get a full circle here.
Well, we are. And don't forget 5G. I mean,
biggest
requirements on PTP are really in synchronizing all those cell towers.
Exactly.
If those cell towers get a few microseconds apart, bad things happen.
No, it's very, very true, and that not to be sidetracked here, but 5G is very interesting because there's a lot of misconception. A lot of people believe that 5G has to do with cellular and the connectivity to the portable devices, but it's actually the replacement of the whole core network transport infrastructure that is really the big case here.
Well, there's all kinds of use cases, and remember for the carriers that cell phones still pay the bills.
Yeah, it does.
There is, it really, that part of it does have to work really perfectly.
Yes.
But that said, the fundamental shift in bandwidth of how much bandwidth is available and how much bandwidth can be delivered to a given device, it becomes an enabler of all kinds of applications, many of which are interesting to the television customer. And so
absolutely
5G is going to change how we do backhauls and contributions and remotes.
When we then get the latency levels down to maximum, a couple of milliseconds between, reasonably distanced hops, etc., completely new applications can be had. Because suddenly synchronization between multiple data centers, video data centers maybe, that then can do various bits of the processing without actually stepping out of sync. A lot of this isn't as easy as it could be potentially today, but again, it's moving very fast.
Well, sure, and latency is an interesting artifact. So we had in one of our first big IP deployments with a customer where they were doing play out in a data center that was 200 or 300 kilometers away. There was a lot of worry about the latency, and so we used JPEG 2000 at the time. You would use JPEG XS today. We used JPEG 2000 at the time with stripes and ultra low latency and all that. And we got the net delay of the whole system down just by focusing the right technology on it.
Yeah.
And the, of course, software-based playout system that ran in the data center, it had some latency, but it was again optimized reasonably.
Yeah.
In the end, when we compared the net system with the system in their plant today, well, the system in their plant today, everything was SDI. So you say, oh, well, it has no latency. Well, that's not true.
That's not true.
In SDI, because of the mentality that the output of everything has to be realigned to vertical,
Yes.
each box that touched the signal added a frame of delay. And
Exactly.
so the net delay was not so different between going off to the data center hundreds of kilometers away and coming back versus going through all the frame synchronizers that were in their existing air chain.
It's very, very true. It's like some of my best kind of argumentation is that whenever you add SDI cable, even if it's just so long, you add 2 frames because it's a frame buffer in each side. And worst case scenario, it's always 2 frames. And you know, you will then insert a lot of different equipment into that you know, chain. Then suddenly you have huge delays. And I'm this you know, crazy old fart. So I've been through analog, and with PAL here in Europe, you know, it was instant. It was really, really instant until, of course, digital came and blew all that away. And IP has this very fine ability, especially with the 100 gig speeds or beyond, to get back to that real-timeness. And that's one of the most exciting things for me.
Indeed. And one of the interesting attributes of the IP system, you know, compared with SDI and the way we used SDI, is that in SDI, routers are kind of a fixed size. And if you need one more port, boy, that's difficult. But if you think about the IP architecture, everything is wired back to the switch, which means that everything is routable separately.
Exactly.
So you don't have to concoct these kind of air chains.
No.
Instead, you assemble it live out of a pool of equipment.
Yeah.
Now, don't get me wrong, SDI does great work.
Yes.
You know, when it meets your requirements, it really does meet them well.
You know, this is a great segue over to some of the things that, because I read a fantastic article that you wrote for, you know, TVB Europe. And that was very, very, very nice. But as you say, we need a way to coexist. And then let me quote you here, because I got one of the quotes which I really loved. I have learned one universal truth. If a piece of equipment still has an ounce of life left in it, broadcast engineers will not throw it out. SDI hardware and SDI itself, it still works. Oh, I love that, because it's so much true. It will, of course, coexist for a long, long time.
Absolutely. And the notion that there's some inherent battle going on.
Yeah.
You know, it's, I suppose if you're trying to sell newspapers or whatever all these online trade publications now, if you're trying to sell ad space on TVB or some other publication, and they all suffer from this a bit, you have to create an air of controversy.
Yeah.
And this is not necessarily a case where there's an air of controversy. I mean, there are different vendors. We all have slightly different ways of thinking about things. But this movement to IP-based technology has been a lot like other projects I've worked on over the years. You know, I worked on the Grand Alliance system, for example, in the US, where, you know, it was 7, 8 competing companies who had very different views at the beginning of it. But in the end, we realized that putting aside the commercial issues, getting a technical framework in place served the industry and fundamentally served all of us better than a continued battle. And I've worked on a number of projects over the years that have been multi-company arrangements. So when the opportunity came along to work on SMPTE 2110 and again do this trick of figuring out how do we get all of the companies who fundamentally we all need to eat, but at the same time, there's parts of the industry where standardization is important. So developing signal layer standards that are truly standard and that everyone does the same way is important to creating a marketplace that then
Absolutely.
all of us can compete on functionality, as opposed to, you know, some other ways you could approach the problem. So early on in the development of IP, the industry, I think the television industry, we did a good job of getting on top of the standards process. I'll give a shout out to Rich Friedel from Fox at the time. He's still at Fox, where he really stood up and kind of gathered everybody in a room from his bully pulpit of being a customer and said, y'all are going to work together.
Yeah.
It's not an option. You have to do it.
Yes.
And so we all, you know, they got together one way or another. Ames was a big outcome of that as well, of a co-marketing alliance around the standards we were all working on.
Yeah.
So it's been a good process that's led
Absolutely.
to a good result, where we now have an interoperable standard. We have dozens and dozens of vendors building equipment that speaks it, and by and large speaks it successfully. Interop is the norm.
Yeah.
So if you go put together a project with 2110 devices, likely they will plug together and work reasonably well. Including, by the way, the control layer, the AMWA NMOS, has also been proven in as a interoperable piece of a solution.
Absolutely, and you know, as you say, interoperability to a certain level is the building blocks of everything, and without that kind of layer, first of all, of course, vendor interoperability, it doesn't matter, but again, vendors would be shooting themselves in the foot by not adhering to these standards, because again, you are not starting from scratch here. You have a lot of equipment you want to incorporate into it. It has to have a basis of understanding of how normal or at least current TV production equipment work. So it's very, very true. And I'm very happy that those initiatives were taken and we can now see the fruition. I remember Interops just, you know, 4.5, 5 years ago, where everybody was struggling to get to the same kind of planet. A year later, everybody was there, and then suddenly finessing, you know, interoperability. And now that is, as you say, today that is not even a question you need to ask.
Yep, it's been a really good road as an industry. It's caused a lot of collaboration.
Yes.
And those interop events had a secondary effect as well. Whereas, you know, we all sat in the room together and worked hard all day as engineers, and then we all went out at night and had dinner. We'll say.
Thank you.
And it really had the effect that as an industry now, there's a lot of just people who know each other across all the vendors. So if we do see an issue at a customer, we know a person at the other company, and we can call up a person that we've met and say, hey, I'm seeing this, we're doing that, you know, help us get to the bottom. And this has had benefits in many projects where small issues can get addressed quickly without needing to necessarily aggravate the customer.
Yeah, you're very, very right. I want to move on to the next quote. And it touches on what you said earlier, because SDI Crosspoint routing has some built-in breakpoints. If you have designed a system around, say, a 288 times 288 SDI router, then as sure as the sun rises in the morning, someone will discover a pressing need for a 289 source. And boy, do I recognize this one. Of course, there is no end to it, is it? Because if you want flexibility by having a routing capability in the core of your system so that you can route whatever to wherever, there is, and the need will always be larger next week, next day, etc. And with IP, it doesn't matter.
Well, I mean, it matters a little. There are breakpoints in IP. But they're in vastly different places. Yeah. I mean, I was looking at some different switches the other day, and you know, there's people who make like 40 and 80 port monolithic, you know, single box, 100 gig per port, 80 port switches. That's a lot, you know?
That's a lot.
I mean, you multiply that out, even at 1080p, that's a lot. And that's still a small switch.
Yes.
Then you get into the current crop of 400 gig switches, and
Exactly.
they only have 24 ports ish, but that's 24 times 400 is a
Yes.
pretty big number. And by the way, that's like a 1RU switch. That's the
Yeah.
small one. And then they get bigger.
Yeah.
So definitely the IP fabrics have some breakpoints. They do. But the breakpoints are in a very different place and you can stay far away from them.
Yeah.
SDI routing, the Crosspoint chips really are
Yeah.
288 squared chips. And by the way, in 12 gig, that's a pretty tricky
Yes.
chip, that 288 port 12 gig Crosspoint. So, yes, you can build a 12 gig SDI router up to a certain size. It works fine. When you start trying to build bigger than that core Crosspoint chip, boy, does that turn into an exotic project.
It's very true, and also as you also stated in its excellent article, was that 12 gig SDI is well and fine for a lot of purposes, and there's still usefulness, of course, but when it comes to a longer range options, like if you build a TV center in bricks and mortar, you will definitely struggle a bit because of both such an easy thing as cable length.
Oh, for sure. And remember that television facilities, you think of them, they're purpose built. So you at least have some maybe flexibility on, maybe the studio is above the machine room or something.
Yeah.
You can play with 3 dimensions. Many times we're building television infrastructure into a facility that has another purpose,
Exactly.
like a football stadium.
Yeah.
Or an arena for basketball or hockey or baseball, where some of those camera positions, or if you think about where the scoreboard is or where the far side cameras, it's really far away.
Yes.
I mean, it's like a 20-minute walk
to
do a lap around some of these facilities. And so, you're definitely into fiber, even if you were doing normal, 3 gig SDI. But, 12 gig SDI does work within its reach. 12 gig SDI on fiber, that works, has some reach. It's pretty good. It is interesting, the 12 gig hardware, some of it, the jitter is more than you'd expect.
Yeah.
And, as much as there's a 12 gig SDI standard that says the jitter shall be less than this, the reality of some products we see out there is kind of interesting.
Yeah. I like that you emphasize the interesting, because that's we'll leave it at that, because of course we are talking about IP where, well, if you then have some fiber stretch, you're much better off putting it on top of IP, of course. But let's move on, because I have another quote from, again, this excellent article. SDI with embedded audio is clearly the evil we know, but it's still sometimes nefarious. When do we need to think about changing up? Where does the conversation about IP start? Well, it was kind of an unnecessary quote, because I think we've been to this one and discussed it. But I still think it's a very, very good point. Because again, the subjectivity of everything being encapsulated in their own kind of transport has been very, very good for a lot of people on how to think. But it's not exactly good for production, is it?
Oh, exactly. I mean, SDI is super appealing if you like everything bundled together.
Yeah.
For example, we build a lot of playout centers. And in playout centers, often you want the whole channel, the whole program together on one wire, goes off to the encoder. Boy, that's simple. But on the production side, you've got the audio and the video, they come from different places, they go to different places. When they are together, it's because you had to put them together.
Yeah.
And if they show up together, you almost always have to take them apart.
Yes.
So having everything embedded is more of a curse than a benefit in some of these systems. And if you look at SDI routers, the big feature in SDI routers is that separates the simple ones from the complex ones, is that in the complex ones, you can buy input and output cards that have audio disembedders and re-embedders on them, and then a whole, many thousand channel audio matrix inside that same frame with the video routers. So we solve these problems every day, but that doesn't make them non-problems.
Yeah.
That SDI router frame with muxes and demuxes on every input and output, and the separate audio matrix in there, and it's all bundled together. Boy, that's a super complicated thing to install, commission, everything else. And so it works. It makes great television, but you can't call it simple.
No, that is very, very true. And that's where, sometimes you need a more complex underling to be able to simplify production. And I feel very strongly that, some of the IP architecture is exactly that. It may seem, and it is in many respects, more complex, but the end result is more simplicity for the user and for the individual engineers that actually need to do separation of paths. And so in production, it's great. But, I have one more quote for you, John. And this is one of my favorites. Greenfields are a luxury, not the norm. Infrastructure refreshes and upgrades are the reality, and indeed a real necessity. A common approach is to add ST2110 islands and beachheads as you redevelop your legacy architecture, gradually moving towards IP, but interconnected with the SDI plant of today. And isn't that true? Because that goes back to the first quote that, broadcast engineers, the really good one, they never throw a bit that works away, do they?
They sure don't. And even many greenfields are really a building being built next to the old building.
Yes.
And they're going to operate in parallel for a little while
Exactly.
before anybody throws the switch and decides we're really only running in the new building.
Yeah.
So this interoperation, frequently in the old days, people had refresh cycles. And so every 8 or 10 years, you'd update the switcher. Every 8 or 10 years, you'd update the cameras, maybe update the lenses on a different cycle. Maybe you update the graphics. And one of those items was the router.
Yeah.
And so now the router stops being one of those items because the router suddenly is a different animal. The router is a different kind of cloth. You can't necessarily just replace your SDI router with an IP fabric and a bunch of gateways. I mean, you could. We love that kind of project, but it's unusual because the economics are not
exactly
awesome. So typically what happens is that the refresh of what used to be the router gets tagged on to the refresh of the switcher or the playout or the cameras or some other piece of the infrastructure.
Yeah.
So that when you move part of the core to 2110, you also are moving one of the real processing elements to 2110.
Yes.
And then you get this dichotomy of, well, what about everything else? And this is a spreadsheet exercise. And broadcast engineers love spreadsheet exercises because they can engineer it.
Yes.
And so you can analyze and say, well, if I just put a gateway on every other SDI thing and go straight to IP, I'll need this many gateways.
Yeah.
If I leave my SDI router connected to those things and put a smaller number of gateways between that and the IP infrastructure, maybe I can get away with a different number of gateways, but have a more complicated control environment.
Yeah.
Okay, now I'm trading off two things. That's engineering 101. How do I make that trade-off? What's right across all of the technical and non-technical factors? Now, a third element in this whole crazy decision tree is that a lot of modern products like ours have, they can be a gateway, but then they have other features that you can turn on later. So you can say things like, well, I'm going to use this as gateways today, but then it's going to become more multi-viewer channels when I update the multi-viewers next, or it's going to become, more video processing channels. It'll be all my up-down crosses when I need that. And so that's another whole axis of trade-off that never really existed in the SDI world.
No.
In the SDI world, you bought little cards, you stuck them in the frame, they did what they did. If you stopped needing them, they stopped being useful.
Yes.
But in, one of the promises of software-based infrastructure and why people are so excited to move everything into the cloud or into software is this notion that it separates the capitalization curve of the computer from the capitalization curve of the software licenses.
Exactly.
Well, we do the same trick in hardware products, quote unquote, where again, it's a platform. It can do a lot of different things, and you can choose your investment strategy carefully, knowing that you can do a simple thing today and add some features and do a more interesting thing later with the same unit.
It's very true, and you know, we got asked the question in a different seminar we did a couple of months ago, where it was that, you know, what was the kind of lifespan of a high-end IP-based switch, and you know, we've been using a lot of equipment for many years, and we've seen that as long as they don't break and is fairly modern, we just move them from the core outwards towards the edge. We never throw it away. And what you also said about a typical, you know, kind of like a converter box, it will switch its purpose. It can also be easily upgraded from, you know, 3G to 6G to 12G. And a lot of those things makes for much longer types of life cycles than the, let's say, the former realm, if you like. And the other benefit is, of course, you don't need to switch your whole infrastructure. Keep the OM3 or an OM4 fibers there, and you will always be able to increase continuously the system's bandwidth. And I find that to be, you know, one of the best arguments. I never liked the arguments that this is so much cheaper, because that's actually not the point. It's the more flexibility that you can add, and also, of course, to whatever frame rate and resolution of the project you decide, because the network is agnostic to it.
Right, and it's important, and I have to remind our own engineers about this from time to time, that television customers are not purely in the, you know, cheapest possible cost business. So saying something is cheaper, well, cost matters, don't get me wrong.
Yeah.
Fundamentally, our customers are also in the risk avoidance business.
Yes, very good point.
They're in the stay on the air business. They're in the systems that can be managed by the staff in the plant business. And increasingly, they're in the, this infrastructure can do whatever becomes important next year, even though I haven't thought through it yet. So that's, to me, one of the most interesting parts right now about where we are as an industry, is that if you were designing a facility 10 years ago, you would design it for HD, and you would make sure it was 1080p capable, because you knew that somebody was going to want to do 1080p eventually. And that was kind of it. And you were good, you know, 3 gig SDI, make sure all your patch panels are good to that. You've done your job. Well, now we have all these simultaneous technology changes. You know, we think of, oh, IP is important. Well, in the production world, UHD and HDR and wide color gamut are all competing for attention. And that there's been maybe a bit of a, you know, while we're on COVID leave, maybe we, you know, COVID situation, maybe there hasn't been quite as much adoption of HDR, but I think once people get back to staring at the studio monitors, we're going to see a little boomlet of HDR production, wide color gamut utilization, even in 1080p, that, you know, because that looks good. I mean, the TVs people are buying for their homes are UHD and HDR and quite a nice color gamut. And so, and the cameras that people are putting in places largely also can produce very nice color gamut, produce very nice brightness range. You know, is it fully HDR? Depends on what camera you buy. But everything else between is infrastructure. And so the productions compete with each other. Television set manufacturers compete with each other. They compete on how beautiful and bright the picture is. So
they do.
The need of a facility now is not so obvious, right? Because the need of a facility now, you have to have a strategy of, how am I going to do UHD in this facility? How am I going to do HDR in this facility? Or all these, you know, even if I have up converters to 4K, do they do HDR correctly? Do I even know what correctly means yet?
No, but it's very true.
Experimentation is interesting.
You're right. John, I would love to spend the rest of the evening talking to you about this. It's something I'm very passionate about, and I must say that, you know, oh boy. This is just awesome. And again, thank you so much for writing that excellent article in TVB Europe. Here's you know, the web address for that. Please, everybody, go and read that article. It displayed the essence and reality of where we are today. Also, John, I must thank you so much for joining the show. That was much appreciated. I totally dig it. And of course, you know I'm a big fan of Imagine. I can tell you a secret. Don't tell it to anybody. But of course, we're using 2 Selenium boxes for all our different necessity of conversion here in this IP-based studio. So yes, you are on the air as we speak.
Oh, and to be honest, we have a couple of nice BridgeTech units in our development labs, and they're one of our gold standards of, you know, it's not right unless the BridgeTech box says it's right.
Oh, thank you very much, John. That is much appreciated. Thank you so much. You know, I know it's morning at your place, so I just want to say, you know, have an absolutely phenomenal day, and thank you for joining.
Glad to be here. See you.
And to everybody else, just to remind you that next Tuesday we have more live from our IP-based studio here in the basement of Bridge HQ. Until next Tuesday, I bid you farewell.